All right, so we have another example here. I have it already kind of worked out. I just took a screenshot from the book. This is on page 497. If you want to look at further, if you want to read further about this example. And so what we're looking at here is we have a system of equations, and we have begun our work by eliminating our variables to write this using our row echelon form. So as we begin to rewrite our system, we start eliminating, and then we get to this point here where we have something that does not make sense. So we have done all of our operations, we've added equations together, and we get something that is not true. This is what we call an inconsistent system, and that means that there's going to be no solution. So there is no solution to this system. So just like we saw before, we know that perhaps maybe two of our equations might intersect, but that will not be true for all three. And remember, to be a solution to the system, it has to be a solution for all three equations. So there is no solution to this system because of this inconsistency here we found as we started to restructure our system. So we're going to go ahead and look at another system that I have written down here, and I'm going to go ahead and label my rows 1, 2, 3. And you don't have to label them. You don't have to record your steps every time, but if it's helpful, then I encourage you to do so. And I like to do that in my notes so that if you're going back and looking at it, you can make sense of my work. So we are trying to solve this system. And what will be helpful is for us to start eliminating some variables. So what we can do is add the first equation to the third equation to replace our third equation. So I'm going to say we're adding 1 plus 3 to replace 3. So I'm going to copy these first two. So those are the same, my equation 1 and 2. And so what I need to do is add my first and my third equation together. So I'll just show that work off to the side. And again, you don't have to if you're feeling pretty comfortable, but if you like to see that, I'll go ahead and work it out. So it's going to be equal to 0. So our new equation will be 3y minus 3z equals 0. And now I can add -3 times the second equation to the third equation to produce a new third equation. So I'm adding, let's see, I'm adding -3. So I have -3 times my second equation to the, well, I guess this would be equation 4, to equation 4, and I'm going to replace equation 4. So let's go ahead and do that work off to the side. So I have -3 times my second equation. And then I'm going to add that to, so that equals -3y plus 3z equals 0. And then I'm going to add that to my third equation, which is 3y minus 3z equals 0. And what I notice is that everything eliminates. So I have 0 equals 0. So what does my new system look like? I have my first two equations the same. And then I have this equation 0 equals 0. So what does that mean? So similar to what we would call like infinitely many solutions, we can see that's going to be true for this equation as well. However, we can't just stop and say, hey, infinitely many solutions. We do have to give a structure to our solution, because we can't just start plugging in random numbers. They still have to follow a specific pattern because we're talking about 3 planes intersecting. So chances are we're not going to just randomly pick 3 numbers that will work. So we have to give a little bit more specific of an answer than just infinitely many solutions. So there's lots of ways to write this. So just take comfort in that, knowing that there's more than one correct way to write your answer. And so one way we can do this is we can just say, well, if I rewrite my equation here, I know that this is the same thing as saying y equals z. So I know that y and z are going to be the same value. So just for the sake of writing my solution, I'm just going to say, let's just say y, actually, let's say z equals an integer a. So where a is a real number. It doesn't even have to be an integer. It's going to be a real number. Okay. And what I'm going to do is I'm going to use this a to rewrite my solution, or to give it some structure. So I know z equals a, which means y equals a, right? Because they are the same. And so now what I can do is take these two solutions and substitute them back into my equation. And I'm essentially solving for x. I'm going to see, what do I have to do to this a value to get something that will be true for x? So if we go ahead and substitute that in here, so x plus a minus 3 times a equals -1, I get x minus 2a equals -1. And so if I add 2a to both sides, I get this expression for x. So one possible solution, one possible way to write the solution would be, I write it as an ordered pair. I have x equals 2a minus 1, and then I have y equals a, and I have z also equal a. So now I can just pick any number, any real number for a, and substitute it into this expression, and then I'll get something that will produce a solution to my system of equations.